Okay, everyone, thank you for your patience. We are going to go ahead and get started. My name is Carlos Albin with ITS America, and I would like to welcome you to this ITS4US Deployment Program webinar, which is being sponsored by the U.S. Department of Transportation's Intelligent Transportation Systems Joint Program Office. Today's webinar is presented by the University of Washington Deployment Site and will focus on GTFS-Pathways, advancing indoor transit data interoperability with accessibility first principles. So here is a copy of today's agenda. The purpose of today's webinar is to share insights about the mapping indoor transit environments for accessible navigation. To kick us off today, Kate Hartman will provide an overview of the ITS4US deployment program. Then Anat Caspi will describe the Transportation Data Initiative and discuss mapping indoor transit environments for accessible navigation. Once the presentation portion has concluded, we will open it up to stakeholder Q&A and share information on how to stay connected with the program. So, a quick overview of today's webinar protocol. As you may have noticed, we have kept all participant lines muted, and that is to avoid any background noise for our presenters. We do ask that if for any reason your line is not automatically muted, please make sure you have self-muted your phone line. As always, we encourage you to provide any questions you may have in the public chat pod, which you will find on the lower right-hand part of your Adobe Connect screen. Time permitting, our presenter will attempt to address as many questions as possible when we get to the Q&A portion. For those who may need closed captioning services, you can enable the live captions by clicking the CC icon at the top cursor of your Adobe Connect screen. Lastly, today's webinar is being recorded, and a copy of the recording, along with the presentation slides, will be posted to the ITS4US Deployment Program website in the near future. If you registered for this webinar, you will receive an email to inform you when the materials have been posted and are available for viewing. So with that, I will now turn things over to Kate Hartman, who is Chief for Research, Deployment, and Evaluation with the ITS Joint Program Office and the University of Washington Project AOR. Kate?
Thanks, Carlos, and good morning, everyone, especially to the UW folks, as we're on East Coast time and it's awful early out there. So delighted everyone can join us. As Carlos said, I am with the ITS Joint Program Office and am the Agreement Officer's technical representative over the UW project within the ITS4US program. As many of you know, because you've been following along, the ITS4US program is a multimodal deployment effort being led out of the ITS Joint Program Office, but supported by the Office of the Secretary, multiple offices within Federal Highway and FTA. And this program supports four large-scale replicable deployments to address the challenges of planning and executing all segments of a complete trip. The ITS4US vision is innovative and integrated complete trip deployments to support seamless travel for all users across all modes, regardless of location, income, or disability. And we have found that these deployment programs work best following a systems engineering process. We did some pre-deployment activities where we gathered thought leadership and interest and ideas around how to best move forward with the program. We went to a fully open and competitive procurement activity for the phase one, which was the planning cycle. Phase one for all the sites have been completed, and all the phase one systems engineering planning documents are posted on the ITS4US website. We are currently in phase two, which is the design and test portion. When this completes, which for across the program is up to 24 months, we will enter phase three, which is operate and evaluate. Again, all of this work is being documented through the systems engineering process, and all of these documents are publicly posted on our ITS4US webpage as they're completed and reviewed. We also have an additional phase, which is not government funded, but which is part of the planning, which is for the sites to plan to operate and maintain their project for up to 5 years after the completion of phase 3. As I mentioned, we have 4 operational ITS4US deployment sites. This one with the University of Washington. There is also the Heart of Iowa Regional Transit Agency, the Niagara Frontier Transportation Authority in New York, and the Georgia Department of Transportation project, all of which are having webinars at various times to talk about their projects. And I hope if you have an interest, you are signed up to these webinars and can listen in on them. But the webinars do get posted as well after they've been completed on the ITS4US webpage. With that, I'm going to turn it over to Anat Kaspi for the meat of the presentation. And Anat, it's all yours.
Wonderful. Thank you. Good morning, everybody. Thank you, Kate. My name is Anat Kaspi. As mentioned, I'm presenting work today that was done through my group on GTFS-Pathways, mapping indoor transit environments for accessible navigation. And, oh, great. I am in control of the slides. That's great. So who are we? We are the Transportation Data Equity Initiative, which has a much larger team. Today, I'm speaking as the development lead for this effort. I'm also the director of the Tasker Center for Accessible Technology at the University of Washington. The TDI is a collaboration among a number of different partners, including the Tasker Center, UW TRAC, which is the Transportation Research Center, along with outside partners to the university, including Sound Transit. I saw many of whom are on this call. So a little bit about our background and the work we had done before, and that gives you a bit of an insight in terms of our intuitions and how we came onto this problem. So through my group, we've been working for the past 6 years on developing a data schema to standardize and make consistent the collection of outdoor path information for pedestrian ways and sidewalks. And so our approach has generally been very much focused on co-design, working with partners, both community partners as well as potential producers for that data, to understand how can we create data specifications that are both sufficient for the travelers who need the informational gaps closed, but also are approachable and collectible by the data producers. And so, as you can imagine, there's often a tension there between what kind of data production can be done consistently and in a standardized way versus all the possible information points that travelers might need. And so a lot of the work that we had done in the past in the outdoor space has been focusing on identifying ways to both create criteria for what makes for good data schemas, as well as identify ways that tooling ecosystems can engage those producers and consumers. Because our belief is that if we make the data production and data consumption easier and more interoperable, then more people are willing to come to the table. And so what you're seeing on this slide is 3 different data products that kind of preceded the work of the Transportation Data Equity Initiative, which were Access Map, that is a consuming application that is currently targeted for people with mobility limitations and providing those information points about pathways. For example, what are the path widths? What are the inclines there? And in addition, it provides for routing with specific constraints. So as a user, you might be able to say, okay, today I'm unable to go up paths that are greater than 8% grade. Please give me the path that's accessible to me as opposed to the shortest path. And so these are the ways in which Access Map is able to use the Open Sidewalks data schema and provide customized routing in the outdoor spaces. And so we've had that experience previous to this, and these are the kinds of intuitions that we're bringing to this question of how should we approach indoor mapping specifically in transit spaces. So the goal of today's presentation is threefold. First is to surface and highlight the stakeholder needs for mapping indoor transit environments and why we ought to do it in a consistent way, and specifically look at accessible navigation as one of the main use cases for this data schema. The second goal is to identify the challenges and open problems in actually collecting that data. How do you map indoor spaces? And the third is to identify several internal mechanisms and collection processes for building routable indoor data. So just to put it all out there, the bias therefore is that we are looking not only to collect data about the spaces, it's not just about digital twinning, but it really has the focused use case of routable indoor data to present accessible navigation options for travelers who experience challenges with these indoor environments. And I would argue that all of us experience challenges with some of the transit environments. And so this type of data collection and also thinking might enhance the way in which we think about these spaces in general. So let's see, we do have a video here. It presents a particular traveler traveling through a transit facility. Let's try it out. I don't know if you can spot, there's a person with a security vest attempting to travel through a station. It's not really clear, but there is a tactile surface which he's following. But it leads him to the midway between the two escalators, and he needs to identify how to navigate to the correct direction.
First Avenue is over here.
So once he's off, I think in the large open space, that's where a lot of the challenges do really come to the fore. He needs to find I'm going to stop this video because great, thank you. So what are some of the challenges that we see there? And this was part of our study, is actually just go along with travelers trying to identify some of the specific aspects of the environment that we can codify and make consistent so that the information is available and people find themselves less like seeking for directions, but having more directed information about the space that they're about to engage with. So some of this is about prospective data engagement, like providing the data standard in such a way that it would allow some downward consumption tools to provide things like trip concierge and pre-trip planning that allows you to kind of navigate through that space, both in visual and audible ways. So part of our downstream project is partnering with Audium, which is a product of XR Navigation. That is a team that has been very both vocal and engaged with providing audio tours basically through an avatar of spaces, both indoor and outdoor spaces. And so we're through this project, we're making sure that the data schemas that we're promoting would actually be consumable by those tools. Let's move on to the next slide. And so, so with respect to our work, we had a different research agenda that we were pursuing. We needed to understand what information is needed for routing in indoor spaces. What information do people with disabilities want for routing in indoor spaces? But we also, as I said, need to understand the tensions with the needs as well as the producers' needs, like what data formats are currently available to producers. What are some data specification enhancements that we might be able to make in order to make accessibility first information available within them? And then what are some tooling contributions that we might be able to make to improve indoor mapping capabilities? And this last statement sounds very like, technology first. So I do want to say that it has to do with the statement I made earlier, which is that we're really focused on building the easy to use human facing tooling ecosystems to improve the use of data standards in mobility data. And so that's where that question comes from. So when working with people, with participants, like the person that you saw who is a deaf-blind traveler, we did extensive work with both community members as well as an extensive literature search. We interviewed a lot of people. We followed orientation and mobility specialists. As you saw in this video, the voiceover was of the orientation and mobility specialist, but it was very muffled. I apologize for that. We had several data specification co-design sessions and also followed an ADA compliance architect through actually the same spaces so that we have a comprehensive understanding of those transit locations, courtesy of Sound Transit. And so this, to our understanding, is following a participatory design approach where we really are trying to work with both the data producers and consumers, and the work with some data producers we will talk about in a minute. But then as we talk to people, it was really clear that at times the needs are very detailed, highly specific, and also might be not in cahoots with one another. So some of the work that we've been doing is all about how do we mitigate those concerns. So the voices of the community were about needing detailed amenity information, needing past context. So often they described being in the middle of a large space, like a travel mezzanine, and not knowing what the contextual information is, which direction is what, how to negotiate a large open plaza-like space was one of the main concerns that came up for nearly all travelers. And then specifically for people with vision disabilities, open, no contrast spaces were difficult for them to navigate. So some of our takeaways specifically were that GPS localization presented hurdles in indoor navigation for nearly all travelers. Basically what this means is it's really hard to get that little blue teardrop to be in the right place within indoor spaces. So for travelers who are using their phone to do on-location wayfinding, that presents huge challenges. And one thing that our study did identify is that if waypoint accuracy is within 0.5 meters, that is sufficient for having on-time instructions for people to be able to respond to those instructions in a timely manner and feel confident about their travel within those spaces. So the less backtracking basically was happening in the context of 0.5 meter accuracy. Amenity information served both for orientation and utility, right? So essentially what that's saying is that amenity information like where are the tap card locations, where are the information boards. So that essentially indicated that the more indoor path nodes or locations that were identified with the data collection, the better, because people found them useful not only for, asking questions about using those amenities, like using the restroom, using the lockers, using the information board, but also use them for orientation and identifying where they were in space. The contextual information along paths was a long and sorted question to some degree. Like, what kind of context did people need? Came up in many different conversations. It was really clear that context, not just in terms of direction and heading, but also in terms of would I find the path changing? How do I get to the correct boarding point? Am I still on the right path? People felt very unconfident with long pathways that didn't give them any waypoints or breadcrumbs along the way to indicate that they're still on the right path. So when we say generic nodes, those are nodes that are just along the way with no actual marking. People indicated that they were of limited value to them or potentially more confusing because it would just say, okay, you're halfway through, you're still along the path, but it wouldn't say you're halfway along the path. And so in the context of navigation, that just didn't give them the indicators that they wanted. And then finally, amenity life cycle was something that people really wanted capture in the schema, and that could potentially be difficult for producers to work with. Essentially, amenity life cycle indicates is this particular amenity like an elevator? Is it working? And of course, these are information points that people would want, but you can imagine that real-time type of information is not something that would be necessarily produced for all stations all the time. And so there are lots of questions about how to adequately provide this data to users and make it a little bit more standardized than, say, Twitter feeds or things like that, but at the same time, not necessarily included in the static features of the schema. Much like GTFS static has a GTFS real-time component, which is different and separate and is a different extension. Moving on. Okay, the other part was, as we indicated, our use case was really well defined from the get-go, which was we are focused on providing the consistent data standard that people want as far as closing the informational gaps, but we really want to ensure that the outcome data is also usable by routing algorithms. And so the question of what information do routing algorithms need to know is key to our work. And so in a nutshell, there are like 5 points that routing information needs. Initially, nodes. So these represent the connection points in the graph. Like decision points and stops and amenities, as I mentioned. So as I mentioned earlier, generic nodes, those would be nodes that that might represent a connection, but may not represent a decision point. It's not a turn, it's not a stop, it's an amenity. It's not an amenity, it just represents another point along the lines. And so those were the generic nodes that people said may actually confuse them more than enhance their travel. Edges, these represent the path connections between nodes. So these might be hallways or walkways. And the big question is, what edges do you represent in a large plaza-like space, like the mezzanine that traveler ended up on at the end of that escalator? The representation there is in question, right? Do we only provide people with the edges along the sides of the walls, basically, so that they have detectable edging to walk along? That might be the case for some travelers. We learned from orientation and mobility specialists that some travelers might do this kind of edge walking. Others will use this mechanism of walking to this, what they might think is the center of the hallway, and then projecting out from there. And then others will actually use tactile paving if that is available, to route through those large mezzanine or plaza-like spaces. So does that mean that for the data producers, we require that all those edges are represented? That was a question. Now, weights. So for routing, you need to represent like the cost of traversal on these edges, like the distance or travel time. Those are the typical ones. But in our case, as we have seen that different types of travelers have different requirements and different potential costs to traversing those edges, you can imagine that the escalator is not the right the right path to follow for someone who's using a wheelchair. And so we have to essentially cost those edges differently for different travelers. And that's an important aspect of what we're trying to do here in terms of the data schematization. Direction, these indicates the direction of travel. As you can imagine, in indoor travel paths, that makes a big difference. This escalator only goes down, so we have to be able to indicate that on the data schema. And then finally, the outcome of all of these together is a routable graph to be able to calculate some shortest path between any two nodes. That graph has to be connected, directed, and have weights on the edges. So this is a tiny bit of graph theory for those of you, but those become really important intended outcomes of creating the data schema in these indoor environments. And so we started out just looking at what is potentially already out there to capture this type of information. And the history of BIM, which is the first one we looked at, can actually be traced back to the 1970s. And that's when the concept of building information modeling, BIM, was first developed. And it started gaining a little bit more traction in the 1990s when the cost of hardware and software decreased, and BIM started being used more often. And then in the 2000s, BIM continued to grow in popularity. And now it's actually used in a wide variety of construction projects around the world. And it really has its great pinning in the construction world. So the most common file format for BIM is IFC, and it's open and it's neutral data format that can be used by different software applications. And it's rapidly evolving. So there are different file formats for BIM, and it's constantly being updated to meet the needs of different stakeholders, but really focused on the construction industry. And as BIM continues to grow, it's likely that the file formats for BIM will also evolve to meet the needs of the industry. And so the main question we were asking there is, with having the original construction industry purpose, what are the pros and cons of reapplying this type of standard towards the navigation questions that we were asking with our stakeholders? So the pros is that it does improve stakeholder collaboration. We've already seen in practice how In construction, collaboration has been enhanced by the standard. So can we drive a similar change in mobility data and transportation using the same standard? It also has a comprehensive view of a construction project. So in the indoor space, it might give us the ability to kind of track that life cycle aspect of the transit facility, like the different changes that happen to the transit facility over time could be well accommodated through this BIM format. And it gives also holistic analyses of other things inside the indoor environment, like energy use, air quality, and other environmental factors. So that could be a potential pro for using BIM in this capacity. Some of the cons we identified were that it was hard to learn or use. So the question was, would transit agencies be able to easily kind of use that data and really make it their own and become stewards of that data? They're also really large files. They're hard to handle, to process, to exchange. There was somewhat limited software support. There were few software applications to support BIM. There's no interoperability even within some BIM software. So as I mentioned, there are different data formats even within BIM. And so a software product that might be able to produce or consume IFC may not be able to do the others mentioned here, like BSDD or COBIE. And that was kind of a shocker to us because we thought, well, if everyone's doing BIM, then it might be the same. So that meant that there was limited usability to some of the software products that were already supported out there. It was very difficult to validate the data. So what you see is what you get. You are provided essentially like a 3D model of this indoor space, and there's very little way to address like how to vet and validate certain information about it. It was not hierarchical or semantically separable, so you couldn't really say, okay, this is hallway 1. And I'm running in advance of us a little bit, but Mari Huerta and Phoebe Smith, who are here from Sound Transit, indicated to us that as they were trying to collect some of these indoor data, the fact that you can separate and task the work separately. So today I'm going to address this hallway, or tomorrow, and being able to identify in the data itself, like what it is that you're addressing and collecting today in a taskable manner is really important for data collection, but that was not present in this BIM format. It's costly, and emanating from all this is the dearth in skill and tool gaps, because it's difficult to collect, work with, and maintain this type of data. So we explored BIM. There's a lot. One of the reasons we were so keen on looking at BIM was actually having to do with a lot of BIM mentions by different federal agencies. Even recently, the ARPA-I initiative that's out there has mentioned BIM as a point of creating digital twinning. And so it would be lovely if this was actionable, but it seems like there are many cons at this time, at least in terms of the ability to support that information. So moving right along, the next one we considered was City GML and Indoor GML, and both are open standards for the representation of 3D city models. City GML is used to represent the outdoor environments, whereas Indoor GML is used to represent the indoor environments. It was developed by the Open Geospatial Consortium in 2003, and the first version of it was released in 2008. And it's based on a geography markup language, which is XML-based schema for representing geographic information data. So we're moving to much smaller files from BIM being very large and 3D representations. It's designed basically to be used together with City GML. So it does integrate nicely with outdoor information potentially. Some of the pros we identified again with a lens of like, how do we create accessibility first, navigation and routable data for indoor spaces. The pros were that common data formats, it joined together common data formats for 3D city models, so it could provide for nice integration with indoor and outdoor spaces. It was open. It had wider software application support than BIM. It was well documented, and there was this hierarchical, semantically separable formatting. So it meant that tasking within this is possible, and that an agency can adequately specify like, oh, this is what we call mezzanine 2, and be able to identify the boundaries of those spaces within the context of this schema. Some of the cons there were it was, again, a little bit complex, hard to learn or use. There were still large files, albeit a lot smaller than BIM. The software support was not all there. It's somewhat limited. And for validation, city GML and indoor GML files were still hard to validate, and that could lead to errors. It was costly because the software is costly, not the standard itself is open. And skill and tool gap was difficult to collect, work with, and maintain. And as we found in 2022, there were only 8 open shared city GML data sets out there. So that to us indicated that really, although there is software support for these things, we couldn't find producers that could speak to their experience producing this data. There were just 8 producers out there that we could even identify. So lastly, we looked at IMDF, the indoor mapping data format. It's a data model that's used to describe indoor spaces. Now we're moving into a set of GeoJSON files, which are basically GIS-informed files. They're lightweight. They're a lot more mobile friendly, and it can be rendered on different mobile devices like iOS and Android. And IMDF was first released by Apple in 2017, and it's since been adopted by other companies, including Google and Microsoft. And IMDF is really designed to be generalized, but pretty comprehensive model for indoor locations. It includes features to describe the floor plan of the building, so something of a flexible hierarchical representation, but also the physical and conceptual elements of that space, like doors and elevators and amenities. So that sounded like a good fit. But it also supports indoor positioning, which allows user to kind of track their location within a building. So again, this speaks to some of our goals with the Audium and XR navigation of the spaces. And Apple specifically uses IMDF inside their indoor survey app, which is used to convert floor plans into IMDF format. So some of these companies are supporting tooling for this. And in 2021, the Open Geospatial Consortium, the same one from the previous slide, added IMDF to the OGC standards as a community standard. So that means that IMDF is basically an official acceptable standard by the Open Geospatial Consortium. And a lot of this was appealing for us to consider. The pros, of course, is that it is an open standard and accepted by the OGC community. It has wide software application support. It's shareable, exchangeable, interoperable. It was well documented. It is lightweight and mobile friendly and supports indoor positioning. And it's flexible, extendable, and validation is possible here. Like you can actually validate the specific aspects of the data and connectivity. There were some cons. It's a little bit complex and hard to learn or use. There is a high cost to this because some of the software tooling is for pay. There's a lack of detail, like it's not as accurate or precise as what our users indicated they needed. And there was no support for some of the indoor features that our community members indicated they wanted it. For example, no underground tunnels or escalators and stairs. So again, we're thinking about routing really intently here. And so some of these links were not part of the standard already. And although the tools for this were much easier to use, it was still a little bit difficult to create and maintain the data, although it's much better than the previous two standards we mentioned. So a lot of data was needed to create a map, and some of that tooling is expensive. There's a capital requirement of investing in the collection of this. And so we wanted to remove some of these cons and difficulties in producing the data. So finally, I'll talk about the GTFS pathways where we got here. The idea with GTFS pathways is an extension to the already existing GTFS mobility data schema. And GTFS pathways originated as a data format or a data extension that can be produced in an Excel spreadsheet type. It is an open standard currently governed by the mobility data. It is well documented, although very, very sparse. So there's documentation, but there's very little in there. It's flexible, extensible, and not complex. So Excel can be used to do this. So it's very low cost. But there were still some cons for us in terms of our users. It didn't support indoor positioning out of the box, so you can't really describe the orientation. So for those uses like Audium and XR navigation, that was a hurdle. There's variable degrees of detail. You can provide as much or as little as the agency is interested in providing. So in some ways that may be a pro because it means that at initial stage, the transit agency can provide lower precision data and then build into it over time. And what we were thinking is that establishing best practices would actually be more practical in this stage when agencies are just starting to delve into this idea of producing data streams for their transit agencies. So indicate sort of what is the lowest bar possible and then growing from there in order to accommodate more and more travelers and the information they need. There's not a whole lot of support out there for the tools, and it's difficult to create and maintain this data presently. And there were no current validators. And so in looking at all of this, one thing I should mention is that immediately out of the box, we identified that GTFS pathways could easily be converted into IMDF if we had the sufficient information for routing. Because it's possible to create this kind of GeoJSON file from the pathways files if pathway files had a specific set of requirements met there. So again, if we're talking about GTFS pathways production at a different staging, so stage 1 is kind of like the minimal information needed to route somebody through a station. Stage 2 is to provide sufficient information to be able to convert it to IMDF potentially so that some of the downstream consuming applications would be able to consume that data. But also providing simple human usable tools to create this data and keep it maintained was one of the things that was still not present, but we thought this is actually a gap that we might be able to overcome with some of the work that we're doing for the ITS4US project. And so what we landed on was basically that we intend to enhance the GTFS pathways, both through this extensive work that we did with community members, as well as some of the joint work and collection that we are currently pursuing alongside with Sound Transit. And so what we'll present today is an early prototype of a GTFS-Pathways editor. One of the things that we haven't put in this tool at this point is how to come up with the initial nodes. So we talked a lot about nodes being of import, and of course the base requirements are to at least have the entrances and exits well specified to a particular station, as well as the boarding locations and stops. And so those are sort of the foundational initial nodes, because those would be the sort of source and destination nodes for routing within a station. But everything along the way, right? The waypoints or breadcrumbs along the way that provide people with information about the amenities, the decision points, all of those are currently, not required. And we, at this point, the GTFS-Pathways editing tool that we've created leaves that question to be answered by the transit agency itself. So it's assumed that the data producer comes in with a set of points, initial set of points, that they're ready to create the GTFS-Pathways with. And so I will ask Carlos to show the tool, and I'll speak over it. Hopefully the audio will be a little bit easier this time. There we go. Okay, so for those of you who edit in OpenStreetMap, you might recognize this type of interface. We are harnessing some and leveraging some of the open source tooling for OSM. And what we're doing here is uploading that initial points or nodes file from memory on this computer. And as you see, as soon as we imported them, they show up as part of the map. And then you can see those points as they are on the map background, but we can also remove those the map background to remove some of the clutter. And so one thing that's important about this is that we're able to annotate those nodes, not in an Excel spreadsheet, but rather provide those annotations one by one to identify like what level is this node at, what is the type of node. So using the accepted GTFS pathways schema currently, but it's all promoted in this slightly more usable way that you don't necessarily need to do this all in Excel or CSVs. And so for some of the nodes, if they're imported without that information, the editor allows people to add that information in this way, and you have this spatial ability to see what node you're referencing right there. And again, you can turn on the map background behind it to kind of identify and be able to see like which node am I dealing with right now and what am I annotating here. Then, of course, the next thing we would want to do is to be able to correct any errors that may have been made, or be able to specify a different level. So different levels are available to do here. And one of our future endeavors is actually to separate the levels so that you're able to look at different levels separately. This actually is a one-level station that we're dealing with. If anyone who might know Seattle, this is the ID station downtown. The next point is to be able to produce paths, right? The connectivity along them. And one of the concerns that we heard from our friends at Sound Transit was that it was really difficult to identify which path you're dealing with, because in the CSV or Excel context, you just given an identifier like a number for the pathway. And so providing that context for the edge made it really difficult. Whereas what we're trying to do here is to provide that spatial underpinning to give people the idea of like which pathway am I annotating and how. And in addition, although you can't see it here, we have also been able to attach images of the nodes and the pathways to the paths so that you're able to then identify with certainty, like which path am I annotating right now. What we're seeing here is the addition of that path into the schema. And so we can, imagine how this moves forward. I'll cut through the chase because we are a little bit short on time. What is important here is that you're able to then save, and through the saving, we actually validate according to the GTFS Pathways extension schema. So there is internal validation to this tool, and it will save the file in both GeoJSON as well as the pathways, the GTFS Pathways extension schema. So you get that duality. That means that you can conform and later translate it to IMDF if you wish. And lastly, when we save out, we also save out the change set, which essentially means that you have an auditable record of what changes were made to this file in very explicit terms, like this edge was modified in such a way, the tag was changed from X to Y. And this provides people with a lot of history of how the data file was done and some auditing capabilities on those files, which we felt were important in understanding the progression of how these data sets develop, and also providing the data producers some ability to like play back essentially how the data was developed over time. So I'm gonna stop the playing of this right now. And just to summarize this work, so the editor is open source itself. It allows for multiple GeoJSON and pathways, both as input and output. It is familiar to people who are already used to using the ID editor, and that's been sort of like the lowest bar editor with OpenStreetMap. So we found that it at least hopefully that the initial skill set needed to kind of integrate into this tool would be fairly low in terms of the requirements of understanding. It saves GTFS pathways and the change record, which provides for that audit traceability. It's easily extensible with new nodes and pathway attributes. So you can come back and like reload the file and just add a new section of that transit station, and it's fairly easily maintainable and updatable. We need to do a little bit of improvement on the UX UI. We want to exclude any types of annotations that would not be part of the GTFS pathways. And right now you can pretty much annotate it with anything. We want to add some tooltips. We actually are already doing pathways validation on save. At the time that I wrote this out, it wasn't fully implemented yet. And we want to enable guidance on connecting the indoor and outdoor environments, right? So going back to how we talked about city GML and indoor GML, there's this seamless connectivity that can be created by that. And that was one of the pros of using those data formats. But we believe that with good practices and good tooling, people can actually do this on their own. How to connect the ID station to the sidewalk environment could be something that can be guided on how to do it through the editor, as opposed to requiring a whole new data format that's much more complex than that. So these were some of the considerations that we looked at in order to design our next future work with this tool. The last thing I wanted to demo, and we're almost at time, is that we have also, we're really intent on being able to show that this outcome is consumable. So as I mentioned before, we worked on Access Map, which is a routing application specifically focused on mobility. And let's start the playback of this. So what we're seeing here is first just the Access Map routing tool. On the left, you see a customization card where the user is able to specify what is their requirement regarding street avoidance, like they don't want to be in the middle of a street without sidewalks, and what is their uphill steepness maximum, how much downhill steepness are they willing to take, and do they want to avoid non-curb ramped like steps and curbs that are not ramped. And so what this is showing you is just like that the routing tool in outdoor environments functions as a customized routing application that provides you not necessarily the shortest path, but one that accommodates those selections on the customization card. And so when you get a route, it tells you kind of step by step, start by heading south. It tells you which sidewalk to use of the street, how long you'd be using it for. It's very, very explicit. Like when you cross streets, it will tell you, to cross even though you're still going down the same sidewalk. And so the intent here is really to provide as much information as people might need to follow a path with as little sensory input as possible. And when you inspect the data, it also gives you a lot of information about, what is the surface here, what is the grade here, etc. Now we're moving into the indoor pathways integration. So you see that the routing application, point A starts in an outdoor environment, it's outside the station, and point B was trying to navigate into a position, the boarding position inside this station. The station is demarcated with a light tan background, so you understand that now you're in an indoor setting, but also the directions tell you that now you're entering the station, as you can see in the cards that were shown on the left. Now, importantly, this particular navigator had the avoid barriers or avoid steps turned off. But as soon as you turn it on, it allows for that selectivity of, or being able to identify that, oh, now this route requires use of elevators as opposed to steps or escalators. And so the new navigation route that was provided to this user once that selection was made is one that's without any steps or escalators. And so all of that is provided through the GTFS-Pathways file that was created with the editor that I showed earlier. And again, this is a multi-level station, so it's a little bit more complex. And so you see the use of actually 2 elevators in trying to get from the outdoor area to the boarding area, which is 2 levels up. The last thing we're going to show is how this integrates with GTFS information, so routing information. So here we go back to the ID station that we just edited with the editor earlier. What the request here was for a few blocks away from that station. So now we're trying to navigate from an outdoor environment, like some sidewalk space outside of the Northgate station up on north, to a location in an outdoor environment close to the ID station in the south. And so the resulting route provides not only an integration of the outdoor paths through the indoor station, using the rail facility and back down to the outbound, the drop-off transit station, and leaving that station to the outdoor space. And so everything, what I wanted to display here is just that we are able to take those files that are output from our editor tool and use them downstream in a consuming application, which also gives us vetting capabilities for that. Let's go back to the last slide. Perfect. Thank you. So our summary, the first community goal with GTFS-Pathways was just to, and this was not our goal, the first community goal was creating that extension was to be able to route a wheelchair user through a station. And so our hope with our work is to enhance that and route anybody through a station. And specifically looking at the replicable process for a step-free, vision-free accessibility through a station. And our work concluded that GTFS-Pathways satisfied the current format needs that we identified specifically for routing with accessibility in mind. And it could extend and scale to other formats, and most naturally, GTFS-Pathways would be extensible to IMDF in the ways I described earlier. So our more focused goal around this work was the creation of replicable processes for collecting, vetting, editing, and disseminating this data. And the TDI work was to extend an existing but currently seldom used data format because not many agencies are currently producing GTFS pathway streams, but we want to make that easier. We had a number of working groups, which included transit agencies. And again, I'll give a shout out to our Sound Transit friends here who have been hugely instrumental in a lot of this work. The software vendors as well, including Cambridge, Kizio Digital, consuming applications, which include Google and Access Map Multimodal, which is what I showed, and third parties, including Socialhelden. And the edit tool will be in production by the beginning of Q4 2024, and we are calling for alpha and beta testers beginning in January 2024, and looking forward to engaging some of you who are out there and potentially interested. So thank you so much for your time. I'm happy to take any questions.
Great, thank you very much, Anat. We really appreciate the very informative presentation. And as Anat mentioned, we are now in the Q&A portion of today's webinar. So just a friendly reminder to our participants, if you have not already provided your questions that you may have for Anat and the University of Washington team, now would be a good time to do so. We have received a couple of questions in the chat, Anat, so I think we're just going to go in order of questions received. So the first one we have states, some aspects of such pathways within transit environments change frequently. For example, furniture, movable merchant signs, etc. Do we need to update such information? If so, how frequently? Do we need regulation to be sure such pathways are not altered other than other pedestrians? If yes, but not enforced, these would create barriers. Your comment about whether the elevator is operating is related to this question.
Right. So I think this is a great question. Thank you for asking it. I think what we found, even with outdoor data schematization, is that we want to separate the conversations around static infrastructure and temporal changes in the infrastructure, potentially the way that GTFS has done it, in the sense of like having GTFS static and then the real-time aspects. And while that might seem like we're kicking the can down the road to somebody else, it's also a way to be able to at least engage people in creating and consuming the information about what is statically there and structurally dependable, right? Because, you know, for example, our work with the orientation and mobility specialists, when there is a lack of these nodes that indicate amenities, they end up inventing breadcrumbs for that traveler that you saw, the deaf-blind traveler. The waypoints that they are creating for them are always structurally static, right? They're not going to say, oh, there's a sandwich board here, And that will be your indicator for making a left turn to enter the station here. But they will, identify some kind of chain on the building or something of that nature that is static. So it did seem to us like at least, as I said, the constrained focus that we had on navigation indicated that we ought to really start with a static information. And while the temporal information was really important to a lot of people, certainly the functioning of an elevator is crucial to a cohort of travelers. Um, it's going to be something that might be schematized in a different schema. We believe that we can do it in GTFS pathways, but that does put on the requirement of like republishing the stream on a potentially daily basis, which is probably not possible for many of the agencies that we're talking about. So perhaps separating that out, but referencing the right identifier. So if in the GTFS pathways, even currently, even in the current extension, not the schema extension that we're going to propose in the coming year, even in the current existing one, there are pathway identifiers, like a number that's associated with each elevator or escalator. And so potentially proposing that there's a way to publish a daily stream that just indicates the operational status of a particular indicated elevator or escalator might be the way to go. So it would be an add-on, but not a specific feature of the GTFS pathways. And so what I'm saying is this is really important work. It's important that we establish community accepted guidances about how to publish this in a consistent way, but might not be the initial outset requirement of producing a data schema that everyone can adhere to and follow and actually publish and release on an ongoing basis. I hope that answered the question.
Thank you for addressing that, Anat. The next comment I see is more of a comment, but this was from one of our participants. The ability to link and transition from outdoors to indoors is important. Travelers need to go through both environments.
Yes, thank you. So I referenced this a couple of times in the presentation. The only data format that currently that we looked at that currently allowed for that was City GML with the indoor GML. But we agree completely that that is a very important objective. And so as I think I mentioned in the future work for the editor, the idea is to allow guidance for people to produce those pathways files that naturally connect to the existing outdoor information that's out there, so that in the least it would be seamlessly integrated between, let's say, OpenStreetMap road information and the indoor files. So that gives you sort of an anchor around which everybody has open shared data and they can consume it as well, so that they know how to integrate the outdoor with the indoor environments. Now, the next step is to actually make that happen. And the consuming application that I demonstrated, Access Map Multimodal, is really where that happens, right? Like if the producer creates the pathways file in such a way that it connects nicely with that outside graph, that's fantastic. And Access Map Multimodal can now consume that. And the next challenge that we're facing now is what happens when that pathways file is just about close to being there, but not quite close enough. And so I will say that the integration with the ID editor, the ID station that we showed, incorporates our first foray into addressing that challenge, so that by intent, that pathways file was currently not explicitly connected to the sidewalk graph, but Access Map Multimodal underneath the hood is making that connection so that there will be a seamless transition from the outside, the open sidewalks file or graph for the station environment, like around the station, to the station itself. So that was kind of part of that demo.
Appreciate that, Anat. So this will just be a final reminder to our participants. If there are any questions for Anat and the University of Washington team, please feel free to provide those in the public chat log. I think we have about maybe 3 or 4 more questions here to go before we wrap up. Anat, this next question is related to the GTFS-Pathways editor. Question is, should the base map be black?
The base map. Oh, so in the very first couple of frames of that video, you saw that the base map could be either satellite imagery, which is what we started out with. It could also be the OpenStreetMap sort of base map. We will say that by using, if you use the data and information from OpenStreetMap as a part of your editing process, that will change the licensing downstream for that GTFS-Pathways file. So that might impact people's choice of what base map to use. You can also use pretty much any of the imagery that is currently available through the OpenStreetMap editor, other than just the OpenStreetMap data. And that will not in any way impact the licensing of the data. So the open satellite imagery is one. There are different types of open satellite imagery out there. And there are also sort of open USGS topographical maps that can be used as the base map. The reason we turned it off for the black is to show so that you'd be able to see the creation of the nodes and the pathways. I'm sorry if that was confusing.
Thank you for clarifying that, Anat. So we have 2 questions here from the same participant. The first part is, did the adoption of GTFS-Pathways protocol change the Access Now data schema, or was it fairly complementary already? And as a follow-up, why is it important to be able to convert to the Apple standard from GTFS-Pathways? And this participant also said, great presentation, by the way. So kudos.
Thank you. Access, I'm not familiar with Access Now. GTFS-Pathways extension has been around for a long time. It just seems like people are not currently using it very much, possibly because there's been little pressure to actually produce that data because very few routers consume it. So I don't know the answer to the first part of the question. Could you repeat the second part of the question?
So that participant just clarified they meant access map. So I guess did the adoption of GTFS-Pathways protocol change the access map data schema, or was it very complementary already? And the second part of the question is, why is it important to be able to convert to the Apple standard from GTFS-Pathways?
Right. So really our intent is to make data schemas and standards as available and low barriers as possible, right? Like we acknowledge now, like when I started this journey 6 years ago, I don't think there was wide acknowledgement of how important mobility data interoperability is. And I see a sea change in that. And I also see some of my mobility data interoperability principles co-authors on this call. For any of you who are interested in what those principles are, please look up MDIP and join the effort there. So yay for for moving the needle on that. I would say that's been like a really positive change in the mobility data arena. The goal in making this particular schema interoperable with the IMDF is that, it's not so much that we're trying to promote an Apple standard. Apple opened up that standard and OGC adopted it as a general standard interface, which is great, but it still lacks some of the tooling that makes it easy for agencies to collect that data at scale. And so what we're just trying to do is make things as interoperable and as possible. And we identified that in being able to produce the data that producers are collecting, not just in the GTFS-Pathways extension, but also produce the GeoJSON file, which would immediately be available to IMDF, would essentially allow for that generalization and potentially allow for downstream consumption by the host of downstream applications that are being produced already for IMDF. So it's not so much that we're trying to you know, um, uh, support Apple. It's really more about supporting greater and more comprehensive interoperability. And for those agencies who foresee the potential change out from, right now we're focused on accessible navigation for our travelers, but maybe in the future we can actually use this for digital twinning and maintenance of these transit stations and facilities. This is kind of the first step in that direction. Again, I was really clear about our very focused lens on providing routability, accessible routability through stations. But I think the more different use cases you build for, so while I won't necessarily build out, the way by which that transit station would be digital twinned and the application for maintaining that, if I build for that capability later on, somebody else can build on and leverage my work to produce that capability for transit agencies, thereby motivating them to keep that data updated and maintained much more so than otherwise. Like, if we don't couple these things, then you can imagine the onus on transit agencies to keep the separate data set for navigation, accessible navigation, and then a totally separate data set with separate tooling for that IMDF digital twinning consumption. That just creates bigger barriers and less motivating factors for agencies to invest their time in and resources in producing that data. So what we're trying to do is just facilitate as much as we can.
That makes sense, Anat, and thank you for clarifying that about the data as well. So we have two more questions here before we wrap up. I actually received one via private message. But the next question I have is, what would you recommend for smaller communities that want to update their information to include more accessible pathway information?
Join us. I think so the idea here is really for us to learn from you if these tools still are creating any kind of fundamental barrier in this. My viewpoint on this is that we're really trying to facilitate as much and as extensible a setup as possible. So the more we learn from communities who are interested in doing this, in how these tools can work into their work streams, the better, because that will enhance everyone's capabilities. So you have an email available on that slide, and we'd love to hear from you.
Yeah, and Anat, that's a perfect segue to the other question I received, and that was, how can interested participants get involved with the project?
Yeah, so reach out to us. I do have a survey questionnaire, but it's just send an email. I think we're close contact here enough. That's totally great.
Perfect. Thank you, Anat. We really appreciate it. And having no more questions here in the chat, I think we will wrap up. But before we do, we wanted to encourage you to stay connected with the ITS4US deployment program. On this slide, you will find contact information for Alina Slotchenko, who is the ITS4US Program Manager, and Kate Hartman, who you heard from earlier today and is the University of Washington Project AOR. You will also find contact information for Anat Kaspi, who you heard from today during the presentation. She's the development lead for the University of Washington's deployment site, and her contact information is on the slide. Additionally, you will find information links to the ITS4US deployment program website and a link to frequently asked questions. So thank you again to all of our participants for taking the time to join us, and for those on the West Coast, especially early for you all, we certainly appreciate it, and for your engagement throughout the session. And a big thank you to the US DOT and Anat Kaspi and the University of Washington team for the great presentation on mapping indoor transit environments for accessible navigation. And of course, for taking the time to address the questions that we received from our participants. We hope you all will continue to stay engaged with the University of Washington's deployment site and the ITS4US deployment program as a whole. And we hope you all have a great rest of your day. Looking forward to seeing you online soon. Thank you all.